This is not something that normally happens in Texas. A strong 5, 1 magnitude earthquake just rattled the middle of cattle country, and the strangest part of this whole story is not even the shaking itself. It is something hidden deep underground, an old buried crack in the earth that looks almost exactly like the one responsible for one of the most violent earthquake events in all of American history, happening hundreds of miles away. Stay with me, because by the time this video ends, you will understand what is really sitting beneath the Texas Panhandle and why even scientists cannot fully agree on what just took place there. Let's dive in. Early Thursday morning, before the sun had even come up, the ground shook violently across a wide stretch of ranch land in the Texas Panhandle, close to the Oklahoma border. A magnitude 5. One earthquake is genuinely rare for this part of the United States. The moment most people hear Texas and earthquake together, their minds jump straight to fracking. But let's be honest about something right away. An earthquake of this size would be unusual, even for one triggered by human drilling activity. Most fracking-related tremors are so small, under magnitude 1, that people don't even feel them. Sometimes induced quakes get bigger if drilling happens to hit an existing fault line directly. But what happened here is clearly something different, and it has already made headlines across the country. I spent hours digging through this story, and here's what I found. This is an earthquake that even experts cannot agree on. Let's start with the facts nobody is arguing about. The quake hit at 5:21 in the morning, centered in a quiet part of Roberts County, near the small town of Miami, Texas, right along the Oklahoma line. People as far away as Oklahoma City and Tulsa felt the ground move. Later that same day, a second, much weaker tremor struck hundreds of miles south. No one was injured, and there was no serious damage to buildings. Here's where it gets strange, though. I went through nearly every major news source covering this event, and not a single one agrees on how rare this actually was. Some outlets are calling it the strongest earthquake ever recorded in the Texas Panhandle. Others say it's the strongest in over 100 years. A few are being more specific, claiming it's only the 4th earthquake of magnitude 4 or higher in that region since records began in the year 1900. So, which version is true? And why can't anyone agree on the basic facts of something that happened just hours earlier? Honestly, I think that disagreement is the most fascinating part of this whole story. Stick with me, because I'm going to walk you through 4 completely different explanations scientists have suggested for what's happening underground in Texas. And the most honest answer might be the strangest one of them all. Let's talk about exactly where this happened. The center of the quake was in Roberts County, deep in flat, quiet farmland and cattle country, closer to Oklahoma than to any big Texas city most people would recognize. The quake itself was shallow, only a few miles below the surface, which explains why the shaking spread so far and felt so strong. This wasn't just a small local tremor. It reached all the way to Amarillo, Lubbock, Oklahoma City, and Tulsa. Reports came in from southwest Kansas and even from the northern edge of the Dallas-Fort Worth area. Some people said they felt shaking from a source nearly 250 miles away. Residents near the epicenter described being startled awake by a sound like distant rolling thunder, except this thunder came from beneath their feet instead of the sky. For a region that's already used to real thunderstorms, tornadoes, and hail, that alone tells you how unusual this felt. By the time most people were eating breakfast, hundreds of reports had already poured into the United States Geological Survey. Within hours, seismologists in 3 different states were suddenly paying very close attention to a part of the country that, under normal circumstances, almost nobody in their field thinks twice about. And here's something most viewers don't realize. The Texas Panhandle has actually been quietly shaking for more than 100 years. Records of seismic activity in this exact area go all the way back to 1907. Since then, researchers have documented roughly 20 separate earthquakes in that same general stretch of land. 3 of them, before this most recent one, crossed the magnitude 5 mark and happening in 1925, 1936, and 1948. A few more followed later in 1951, 1974, and 1980. So what exactly is buried beneath all that quiet panhandle wheat and cattle country? This is where the story becomes genuinely old. In the geological sense, there's a fault system sitting underneath this whole region, and it isn't some brand new crack that just appeared. Geologists trace it back to something called the Amarillo-Wichita Uplift, the buried remains of an ancient rift, a place where the continent itself once tried to split apart and never quite finished the job. This failed rift dates back to the early Cambrian period, roughly 500 million years ago, long before dinosaurs existed and long before anything with a backbone had even crawled onto land. So is this ancient buried scar responsible for Thursday's earthquake? Don't jump to conclusions yet, because there are 4 separate explanations on the table, and they might genuinely surprise you. This ancient scar isn't just sitting there doing nothing. It rests quietly beneath the wheat fields of the Panhandle, mostly silent for enormous stretches of geological time, until modern-day stress somehow finds its way back to it. At least, that's one theory. But here's the catch. The numbers don't fully add up. And that mismatch is worth explaining properly. Let's go back to that disagreement I mentioned earlier, whether this was the strongest quake ever recorded in the region, or simply the strongest in a century. The explanation turns out to be stranger than the disagreement itself. An earlier Panhandle earthquake, reported at magnitude 5, 4 back in the 1930s, was never actually measured by any seismograph, because there wasn't one anywhere near that remote area at the time. Instead, scientists back then estimated the size of that earthquake, after the fact, by mapping where people reported feeling the shaking and where damage showed up. In other words, they rebuilt that earthquake using old letters, newspaper clippings, and reports of cracked plaster on someone's living room wall. That estimate might be fairly accurate, but it's built from human accounts, not instrument readings, which makes it very hard to compare fairly with Thursday's earthquake, which modern seismic equipment captured in real time, straight from the ground itself. So when different news outlets call this week's quake the strongest ever recorded, they most likely mean the strongest ever measured by an actual instrument, not necessarily the strongest earthquake to ever physically happen in that region throughout its full history. Once you separate those two ideas, most of the confusion clears up. It's not that reporters are getting it wrong. It's more like comparing an old hand-drawn sketch to a modern photograph and then arguing about which one is more accurate. That distinction points to something a little uncomfortable. The full picture of Texas's earthquake history is a lot blurrier than this week's dramatic headlines make it sound. Which brings us to the 4 competing explanations for what actually caused the ground to shake on Thursday morning. Scientists haven't ruled out a single one of them yet. Explanation 1 is the one we've already been building toward, the idea that this ancient failed rift essentially woke back up on its own. This is currently the leading natural explanation. Tectonic stress slowly builds up across an entire continent over long periods of time, and every so often, that stress finds the weakest point in the crust and releases there. In the Panhandle, that weak point happens to be this same old failed rift system. Under this theory, no human activity is needed at all. It's simply geology doing what geology has always done, on a timescale that makes a whole human lifetime look like the blink of an eye. Explanation 2 is one almost nobody is talking about right now, even though it's genuinely interesting: old oil fields dating back decades. Several historical Panhandle earthquakes, including ones in 1936, 1966, 1974, and 1980, happened directly above major oil fields that were being actively drilled at the time. Researchers who studied those older quakes suggested they may have been triggered by that historical oil production. But those same researchers admitted a real limitation. The equipment available back then simply couldn't pinpoint the exact depth or location of those earlier earthquakes very accurately. So this remains a genuinely open question, not a settled fact. Explanation 3 is the one most people jump to the moment they hear Texas and earthquake in the same sentence. Modern wastewater injection tied to oil and gas drilling, commonly linked in the public's mind with fracking. This is a real, well-documented phenomenon in Oklahoma and parts of West Texas. Researchers have clearly shown cases where pumping leftover drilling fluid deep underground has triggered earthquakes along nearby faults. However, officials responding to this specific Panhandle earthquake have been notably careful, saying plainly that more data is needed before drawing any firm conclusion. A magnitude 5. 1 is genuinely large for a quake caused mainly by fluid injection. And unlike the well-studied cases further west in the Permian Basin, this particular event doesn't yet have that same level of supporting evidence, which brings us to explanation 4. And you might actually laugh at this one, because the honest answer right now is simply nobody fully knows. And in my opinion, that might be the most honest answer of all 4. Within hours of the earthquake, scientists were already saying exactly that in public, that figuring out the true cause of an event like this takes real-time, careful data collection and detailed modeling, and that built-up stress can absolutely reactivate an ancient fault entirely on its own, with zero help from anything happening on the surface. In science, saying "we don't know yet" isn't a cop-out. In this specific case, I genuinely believe it might be the single most accurate sentence in this whole story. But here's the detail that actually stopped me cold while researching this. Geologists studying the Amarillo-Wichita uplift have pointed out that it shares a strikingly similar structure with something called the Reelfoot Rift, another ancient, failed buried rift system sitting deep underground in a completely different part of the country. And that particular rift system happens to sit directly beneath the New Madrid region, where the borders of Missouri, Arkansas, and Tennessee all meet. That is the zone responsible for the legendary New Madrid earthquakes of 1811 and 1812, a sequence so powerful that some accounts from that time describe the Mississippi River appearing to briefly flow backward. To be completely clear, no scientist is suggesting Texas is somehow due for a repeat of anything on that scale. Nobody is predicting a New Madrid-style disaster in the Panhandle. What geologists are pointing out is actually narrower and honestly more interesting than a simple doomsday prediction. Both regions share the same basic geological ingredients: an old failed rift buried deep beneath the surface, silent for hundreds of millions of years at a time, following essentially the same underlying blueprint. One of these ancient scars just happens to sit beneath Texas wheat fields instead of beneath the Mississippi River Valley. So, what happens next? The United States Geological Survey ran its forecast within hours of the quake, putting the odds of another earthquake of similar size or larger in the coming days at roughly 2%. That's small, but it's not zero. Their damage modeling showed low overall risk, mostly because so few people actually live in that rural stretch of the Panhandle, meaning serious injuries or major economic losses are considered unlikely. But here's why the size of this particular earthquake actually matters statistically. The Panhandle has now had roughly 4 earthquakes of this magnitude, or larger, within about a century, which works out to something happening, historically speaking, roughly once every 25 to 30 years. Push that threshold up slightly to around magnitude 5, 6, and the odds shift dramatically. Scientists estimate a quake that size only shows up in this specific region roughly once every 50 to 100 years. Push it further, up to magnitude 6, and you're looking at something closer to a once in 3 centuries event. So this magnitude, 5. One earthquake isn't some bizarre statistical fluke. It looks a lot more like a clock finally striking the hour it was always eventually going to strike. Nobody knew exactly when that hour would arrive, because that's simply how earthquakes work. There's no way to know in advance with real precision. Let's talk a bit more about that second, smaller earthquake I mentioned earlier. The one that hit later the same day, hundreds of miles south of the main event. That quake, measuring roughly magnitude 3. 9 struck a completely different part of central Texas, geologically unrelated to the ancient rift system beneath the Panhandle. It's worth mentioning specifically because it caused some brief confusion online, with people assuming the two events were connected, maybe even aftershocks of each other. They weren't. Texas is simply a large state with several separate zones of seismic activity, some ancient and mostly natural, others more directly tied to modern industrial activity. 2 unrelated earthquakes striking on the same day in completely different regions is really more of a coincidence of timing than any kind of connected event. It's also worth explaining a bit more clearly how scientists actually figure out whether an earthquake was triggered by human activity, since that question keeps coming up throughout this story. Researchers typically look at a combination of factors together. They study the exact depth of the earthquake, since injection-triggered events tend to cluster at depths close to the depth of the wastewater disposal wells themselves. They look at the exact location relative to any nearby active injection sites. They study the timing, checking whether seismic activity in an area increased noticeably after nearby injection operations ramped up. And they compare the specific fault that ruptured against the broader regional stress patterns already mapped out by geologists. When enough of these factors line up together, scientists can build a fairly confident case, linking an earthquake to industrial activity. When they don't line up cleanly, as appears to be the case so far with this specific Panhandle earthquake, the honest scientific approach is to withhold judgment and keep gathering more data, rather than jumping straight to a conclusion. There's actually a peer-reviewed study from 2022 published in a respected geology journal that looked specifically at earthquake activity across the Texas Panhandle between 1983 and 2018. That research found a steady rise in smaller earthquakes, magnitude 2, 5 and above, across that multi-decade window. And it concluded that a majority of those smaller events showed signs consistent with being linked to underground wastewater injection tied to the oil industry. That's genuinely useful context, but it's also worth being careful about what it does and doesn't tell us. That earlier research focused on a large number of smaller, more routine earthquakes accumulated gradually over decades. It wasn't specifically studying an isolated event anywhere near magnitude 5, which is exactly why officials responding to this week's earthquake have been so hesitant to simply extend that same explanation onto this particular event without further investigation. Let's go a little deeper into the New Madrid comparison too, because I think it deserves more context than just a quick mention. The New Madrid earthquake sequence of 1811 and 1812 remains, to this day, widely considered among the most powerful earthquake sequences ever recorded in the history of the continental United States. Multiple massive earthquakes struck that region over the span of just a few months, strong enough to be felt as far away as the eastern seaboard, ring church bells in the cities hundreds of miles away, and permanently reshape parts of the local landscape. Because that region had almost no population at the time compared to today, the human toll was relatively limited given the sheer scale of the event. If a sequence of that same magnitude struck the same region today, given how much has been built up across that part of the country since the early 1800s, the consequences would look dramatically different and far more severe. What makes the structural comparison between that region and the Texas Panhandle genuinely interesting to geologists isn't that anyone expects a repeat performance. It's that both areas represent what geologists sometimes call failed rifts, places where hundreds of millions of years ago, the North American continent began trying to split apart entirely, only to stop partway through the process for reasons scientists are still working to fully understand. Instead of finishing the job and forming a brand new ocean basin, the crust essentially healed back over, leaving behind a long, buried scar, weaker and more fracture-prone than the surrounding rock, patiently sitting there for the rest of geological history, waiting for the right combination of stress to reawaken it, even if only briefly and on a far smaller scale than what happened in 1811. Understanding that shared geological history doesn't tell us exactly when the next moderate earthquake might strike the panhandle again, but it does help explain why this region, as quiet as it usually seems, isn't quite as stable and predictable as most residents have always assumed. So where does that leave us? The ground genuinely shook harder in the Texas Panhandle than any seismograph has ever directly recorded there before. That much is settled fact. 4 separate explanations remain technically on the table, and scientists haven't settled on just one of them yet. And underneath this entire event sits a 500 million-year-old scar carved into the Earth's crust, one that shares its basic structural blueprint with one of the most violent earthquake sequences in American history. What happened in Texas this week wasn't something impossible. If anything, it was something that had essentially been quietly preparing to happen, long before the state of Texas even existed in any recognizable form. That scar was already sitting there in the ground, patiently waiting. If you found this story as fascinating as I did, make sure you're subscribed to this channel, because we cover exactly these kinds of strange, underreported natural events every single week, explained clearly and honestly, without unnecessary exaggeration. Let me know in the comments if you had ever heard of the Reelfoot Rift or the New Madrid earthquakes before watching this, because I genuinely want to know how many of you were already familiar with this piece of American geological history. I'll keep a close eye on any new developments coming out of the Panhandle, and I'll bring you an update the moment there's anything meaningful to report.